Okay, so on notes 6-1, we're going to be simplifying complex fractions. So a complex fraction is fractions on top of another fraction. So we have fractions on top and fractions on bottom. Okay, so our goal is to get rid of all the fractions on the top and all the fractions on the bottom, and then we can simplify the one fraction that we have at the end. Okay, so in order to do that, what you're going to do is you're going to find the LCD, which is the least common denominator of every single fraction that you have. Okay, so we talked about that last unit. If there's only one term, we're going to use factor tree. So if this 4 here, we're going to have a 2 and a 2. So I'm going to bring both of those down to form my LCD. On the 8, we're going to have 2 and 4 and 2 and 2. Notice we already have 2 2's, so I need to bring down another one because there's 3 there. Notice this 2 here does not have, it's not a fraction, so I don't have to worry about that. This one, 2 and 6, 2 and 3. I already have 2 2's, but I don't have a 3, so I need to bring that down. So 2 times 2, we get 4, times 2, 8, times 3, we get 24 for our least common denominator. Once we have found the least common denominator, in order to get rid of the fractions, we are multiplying every single term by the LCD. So I'm going to have 24, go ahead and put it in fraction, times 3/4 minus 24 times 1/8. So all I'm doing is distributing the 24 to every single term that we have. The bottom, 24 times 2, plus 24 times 1/12. Okay, so from here, if you are multiplying by your least common denominator, your fractions should cancel. Okay, so the 4 and 24, those cancel. 4 will go into 24 6 times. So 6 times 3, you would get 18. Reduce this, 8 will go into 24 3 times. 3 times 1, we get 3. Notice we're subtracting, so bring that over. Denominator, 24 times 2, we get 48. And then 12 will go into 24 2 times. 2 times 1, we get 2. From here, we're just adding and subtracting, and then we'll reduce our fraction. So 18 minus 3, we get 15 over 48 plus 2, 50. So when you reduce that, that would be 3 over 10. And that would be our reduced fraction there. So when you're simplifying complex fractions, you're trying to get rid of the fractions on top and get rid of the fractions on bottom, so that way you're able to simplify your one fraction at the end. Number 2, we have a complex fraction again, so we need to get rid of your denominators by multiplying everything by your LCD. So look at your first denominator here, x plus 2. There's more than one term, so you factor using the flow chart. But notice x plus 2 we can't factor, so I'm bringing it down to form my LCD. The 6 is not a fraction, so we don't have to worry about that. This one, our denominator is x. We do not just have an x by itself in our LCD, so we need to bring that down. Okay, so our LCD would be x plus 2 times x. So I'm going to multiply everything by that LCD. So notice that the x plus 2's cancel. I'm left with x times 1 on top, which is just x. Notice in the denominator here, we have an x times x plus 2, but also times a 6. I'm going to go ahead and multiply these two together, so that way I only have one step, and I'm going to distribute those. So that's 6x squared plus 12x. And then notice we have the plus. The x's cancel here, but not that other x. So you'll have to distribute that 4. So that's 4x plus 8. Okay, so we got rid of the fractions on top and fractions on bottom. Now we're going to combine like terms in the denominator. So I can't do anything with the x on top. I can combine these x's in the middle. So I have 6x squared. That would be plus 16x plus 8. At the very end, once you've combined like terms, you need to see if you can factor the top and the bottom. So I can't do anything with the x, so it stays as x. But notice the denominator, they have a GCF of 2, so I'm going to take that out. And then I'm going to see if I can factor the trinomial inside the parentheses. So anytime we're factoring a trinomial, we're using sum and product. So the sum would be 8, product would be 12. So that would be x plus 6 and x plus 2. We are not finished with factoring because notice your coefficient of x squared is a 3. So you need to use the swing method. So divide it by 3. So you'll have an x on top. And then reducing it, that would give you an x plus 2. And then we can't reduce here, so I'll swing it in front, and that's 3x plus 2. From here, check to see if anything cancels. We cannot cancel this x with this x. Okay, so that's as far as we can go. Okay, let's look at 3. So again, we have complex fractions, so we're finding the LCD in order to get rid of the fractions on top and bottom. So notice my first denominator is just an x, so I'm going to bring it down. And then notice my second denominator is 2. We don't already have a 2, so bring it down, but we do already have an x, so I don't need to bring down another one. Next denominator, we have a 3, but we don't already have that in our LCD, so bring it down. We do already have an x, so don't bring down another one. This one here, we can use factor tree. If you can use factor tree, you need to use it because we're not going to bring a 4 down. We're only going to bring down 1, 2 because we already have the other one. And then we have the x. So multiplying those together, you're going to get 12x. I'm going to go through and multiply every term by that LCD. Okay, so notice on the first one, x's cancel. We're left with 12 times 1, so we're going to get 12. Notice second one, x's cancel, and then we can also reduce the 2 and 12. That would make a 6 there. And then 6 times 3, we would have plus 18, because we're bringing over that middle sign there. Looking at the denominator, x's cancel. 3 will go into 12 4 times. So 4 times 1, we get 4. Next one, x's cancel. 4 will go into 12 3 times, but we have to multiply it by this 3 to get 9. So then we're just adding those. 12 plus 18, we get 30. 4 plus 9, we get 13. Check to see if you can reduce. We can't, so that would be our answer there. So our goal is to get rid of the fractions on top, fractions on bottom, so that way we're able to simplify the one fraction. So make sure you're finding the least common denominator at the very beginning and then just multiplying everything by that LCD. Okay, last one. So we need to find an LCD. Notice the first denominator that we have is an x minus 1. If it's 2 or more terms you're factoring using the flow chart, we cannot factor x minus 1, so I'm bringing it down. The other denominator that we have, x squared minus 1, we can factor. That's difference of squares. That would be x plus 1, x minus 1. Notice we don't already have an x plus 1, so I need to bring it down, but we do already have the x minus 1, so I don't need to bring that one down. So there's our LCD. So I'm going through and multiplying every term. By the LCD. Now right here, if you factored your denominator, then make sure that you write the factored form. Okay, so notice here, we're not able to cancel anything out because we don't have a fraction there. So we do need to multiply all that together. You would use FOIL here. The middle terms would cancel, so you would be left with x squared minus 1. The x minus 1s cancel here. We're bringing down the plus. And notice we're left with x plus 1 times 1, which would just be x plus 1. This is the same thing as this. So that's x squared minus 1. And then notice both of them cancel here, but we have to put this plus 1. From here, do not start canceling terms. You need to combine like terms. Notice I can combine the 1s, and they cancel. So that's x squared plus x. Denominator, I can combine the 1s, and those cancel. So I just have an x squared. You cannot cancel the x squareds there. Okay, you have to factor the top. They have an x in common, and you're left with x plus 1. And then your denominator is x squared. Okay, so right here we can reduce this. This means x times x on the bottom. So one of them would cancel and you'd be left with one of them on the bottom. So you're left with x plus 1 on top over x. Same thing here. We cannot cancel those x's because we have an x plus 1 on top. So that would be our final answer there. Okay, so tomorrow we're going to do more of complex fractions, and then we'll get into solving a rational equation.